The lesson topic for this video is exponential growth and decay models. All right, so this example says, since Michael Jordan's entry into the NBA in 1984, the average salary for NBA players has increased exponentially. The average annual salary of an NBA player increased from $170,000 in 1984 to $2.6 million in 1998. First, we're going to write an exponential function to model this situation. Even if I hadn't said write an exponential function, we would have known it is exponential because it says here that the salaries increased exponentially. All right, so let's start by writing our general form for that. Y equals A times the quantity 1 plus R raised to the x power. And what we need to do to write this function is we'll need to fill in a value for A and a value for R. So we're going to have to solve this for R after we fill in an x and y value and an a value, just like we have in previous lessons. So let's talk for a minute about what this a value would be in this situation. Well, since the directions include this part about since his entry into the NBA in 1984, it has increased exponentially, we know that 1984 is the starting point for this increase, this exponential increase. Therefore, we can think about 1984 as our 0 for x, our starting point. So if you think about 0, and in 1984, what were the salaries? Well, the salaries were $170,000 on average. And we're going to write this in thousands, so we'll just write 170 there. So at this point, we know we can fill in A as 170 because it's our starting amount, our original amount, when this exponential growth started. Now we'll still need to fill in an x and a y value so that we can solve for r. All right, so our second data point comes from this situation right here. In 1998, the average salary was $2.6 million. Now be careful, because what you don't want to do is you don't want to write our second point with putting 1998 right here. Okay? What we need to think about is that our 0 was in 1984. So how many years have gone by to get to 1998? Well, that's 14 years. So our next x value is 14 years later. And what is our y value in 1998? Well, it was $2.6 million. Now, since we said we're writing this in thousands, 170,000, we need to write this in thousands. So let's just write $2.6 million. Sorry, my line is there, but $2.6 million looks like this. All right, 2,600,000. So if we're writing this in thousands, thousands comes from beyond these three zeros, so it's 2,600 thousands. So 2600. All right, so there's our second data point. So we know we're going to put a 14 in for x right here, and then we're going to put 2,600 in for y. Now we're going to solve for r. To solve for r, we're going to go ahead and divide both sides by 170. And we get 15.294 equals 1 plus r raised to the 14th. Now remember, what we have to do here is we need to get rid of that power of 14, and to do that we undo by 14th rooting. Seems a little crazy, but we're going to 14th root 15.294. And when we 14th root that, we're going to get 1 plus r on this side still equals 1.215. And lastly, we're going to subtract 1 from both sides. And we're going to get r equals 0.215. So we know our rate is about 21.5% increase every year. So now to write this model completely, whoa, let's not do that. All right, so to write this model completely, we're going to want to write y equals the original amount, 170, and this is in thousands, times 1 plus the rate, which is 0.215, raised to the x power. Now, of course, to finalize writing this, we're going to add the 1 plus the 0.215, and our final answer is going to be y equals 170 times 1.215 raised to the x power. There's the model. Now, what's nice about that is once you get that model, the next question is pretty easy. It says find the average salary for a player in 1990. Well, if we're trying to find the cost for a player in 1990, okay, we just have to put a value in for x so we can find the salary, which is y, right? So the salary is here, the years is here, right? So we have the original amount, we have our 1 plus r, and we need to put a number in for x so we can find the salary. All right, so y equals 170 times 1.215 raised to what power? Now remember, this is a very common mistake. We're not going to put 1990 into our exponent right here. We need to put how many years since 1984 because that was our zero value for x. Well, from 1984 to 1990 was 6 years. So 6 years later. And so we're going to compute this and find out what the salary was, the average salary anyways. Okay, so that will be, when we compute that, 546.898, which means that the average salary for a player in 1990, if we change this because it's in thousands, would be 898, $546,898.